So good morning students. So today we'll be doing some questions of previous year NEET, that is NEET 2024 questions, chemistry questions. So let us start. So first question, arrange the following elements in increasing order of their electronegativity. So we have to arrange these elements in increasing order of their electronegativity: nitrogen, oxygen, fluorine, carbon, silicon. So carbon, nitrogen, oxygen, fluorine, these are elements of the same period, and silicon is below carbon in the periodic table. So we know down the group the electronegativity will decrease, and along the period the electronegativity will increase. So along the period electronegativity increases. So fluorine is more electronegative than oxygen, then nitrogen, then carbon. And down the group the electronegativity is decreasing. So silicon will be less electronegative than carbon. So this will be the order of their electronegativity. So answer will be first option. Next question. Identify the correct reagents that would bring about the following transformation. So we have to convert this alkene into aldehyde. So first of all, we have to do hydrolysis of alkene. If we are doing normal hydrolysis, so this is the alkene. If we are doing normal hydrolysis, then it will follow the Markovnikov addition. So in Markovnikov addition, the OH group will be attached to the central carbon. So if the OH group is at the central carbon, it will never give me aldehyde. If we are oxidizing this, we'll be getting ketone. So we want aldehyde. So the first thing that we have to do is anti-Markovnikov addition. So anti-Markovnikov addition in alkene is done by hydroboration oxidation. So we will be doing hydroboration and then oxidation. This is anti-Markovnikov addition. So in hydroboration and oxidation, to this, if I am doing hydroboration, that is B2H6 or BH3, and oxidation with hydrogen peroxide in basic medium. So the product that we'll be getting is alcohol according to anti-Markovnikov addition. Now the OH will attach to the anti-Markovnikov addition according to this. So this will be the product form. Now from this product I can easily make this by oxidizing this aldehyde, but if I use a strong oxidizing agent, this will be oxidized to carboxylic acid. So I'll be using a weak oxidizing agent like PCC or PDC, pyridine chlorochromate, that will oxidize this only to aldehyde. So if I'm using KMnO4, then this will be oxidized to carboxylic acid. So to prepare aldehyde, this will be the reagent: hydroboration, oxidation, and then oxidation with PCC or PDC. These are mild oxidizing agents that will oxidize alcohol only to aldehyde and ketone. So we cannot use KMnO4, it will oxidize this to carboxylic acid. So the answer of this question will be second. Next question. The compound that will undergo SN1 reaction with the fastest rate. So if we study the SN1 mechanism, so which is the rate determining step? The slowest step is the rate determining step, that is formation of carbocation. So over here we have to look for the formation of carbocation. The more stable carbocation, more easily it will be formed and the rate will be faster. So the rate determining step is the formation of carbocation. So over here, this will give me primary carbocation, this will give me secondary carbocation, this will give me phenyl carbocation, that is highly unstable, and this one will give me benzyl carbocation, that is stable, and also the alpha hydrogen. There are 3 alpha hydrogen, so that will be stabilized by hyperconjugation of 3 alpha hydrogen, and also benzyl carbocation, which is highly stable. So this will give me the more stable carbocation. So this will undergo SN1 reaction easily because the carbocation will be formed more easily. Next question. For the reaction 2A is giving me B plus C, Kc is given. At the given temperature, the composition of reaction mixture is. So this is the composition. So let us first find out a reaction question from this. So concentration of B and concentration of C upon concentration of A whole square. Since all the concentration are equal, the reaction quotient for this will be coming out to be 1, and equilibrium constant is 4 into 10 to the power minus 3. So reaction quotient is greater than equilibrium constant. So this basically reaction will try to maintain its equilibrium by reducing its value. So what will happen over here? The value of denominator will be reduced and numerator will be reduced and denominator will be increased. So Q will try to reduce its value and go towards the value of equilibrium constant. So to reduce its value, the value of numerator will be decreased and denominator will be increased. That means it will move in the backward direction. So question is asking which of the following is correct. Reaction is in equilibrium? No, the reaction is not at equilibrium. Reaction has tendency to go in the forward direction? No, the reaction has tendency to go in the backward direction. So Q will tend towards Kc, that means the reaction will be going towards backward direction to decrease the value of Q towards Kc. So the answer will be third option. Next question. The highest number of helium atoms is in, 4 options are given. So you have to tell highest number of helium atoms. So number of helium atoms will be number of moles of helium into Avogadro's number. So number of moles in the first case is 4 moles. So in the second case it is given 4 AMU. 4 AMU means the atomic mass of helium is 4 AMU. So that is 1 atom. Over here this will be 4 Na atoms. Number of moles into Avogadro's number, 4 Na atoms. Then 4 grams of helium, number of moles of molecular weight of helium is 4. So 1 mole, that means Na atoms will be there. And 2.27, so at STP condition, volume of 1 mole of ideal gas is 22.7 liters. So over here number of moles will be 2.27 by 22.7, that is 0.1 mole. So number of atoms will be 0.1 Na. So the highest number of atoms will be 4 Na, that is the first option. Next question. So we have to match this isothermal. Isothermal is at constant temperature. So carried out at constant temperature. So A is corresponding to 1. Then isochoric is at constant volume, carried out at constant volume. So B is corresponding to 3. Then isobaric is at constant pressure. So at constant pressure, C is corresponding to 4. And adiabatic, there is no heat exchange with the surroundings. So D is corresponding to 1. So A is corresponding to 2, constant temperature. So A2, B3, C4 and D1. So that will be 4th option. So this will be the correct answer. Next question. The energy of electron in the ground state of helium ion is x joules. So we can use the Bose atomic model because this is single electron species, helium plus ion. So E is equal to E naught Z square by N square. So ground state, that means N is equal to 1, and helium ion, so atomic number is 2. So E will be equal to E naught into 2 square by 1 square, that is 4 E naught. So the value of 4 E naught is given out to be minus x joules. That is given in the question. So now that for electron in the second state of beryllium plus 3. So beryllium plus 3 is also isoelectronic species. Now in the second state we have to tell, so N will be 2. E is equal to E naught Z square by N square. We are using the Bose atomic model. So for beryllium, Z will be 4. So 4 square by 2 square. So that is 4 E naught. So that is also coming out to be 4 E naught. That will be also same value, minus x joules. So answer will be first option. Next question. Match the following types. So ethane, this is the molecule, number and types of bond between 2 carbon atoms. So what type of bond is there between 2 carbon atoms? In ethane, so in ethane we are having carbon-carbon single bond, and single bond there will be only one sigma bond. So A is corresponding to 3. Then in ethene we are having carbon-carbon double bond. First bond will be sigma bond, another one will be pi bond. So one sigma bond and one pi bond. So one sigma bond and one pi bond will be there. So B is corresponding to 4. Then C2 molecule. So C2 molecule, you can write down the electronic configuration according to MOT. So according to MOT, if we are writing for C2 molecules, there are 12 electrons. So sigma 1s2, sigma star 1s2, then sigma 2s2, then sigma star 2s2. Then because it is less than 16 electrons, so what will happen? The pi will start filling first. So pi 2py and pi 2p x, you can say that will start filling first, and sigma 2pz will start fill later. So total 12 electrons, 2, 4, 6, 8, 10, 12. So over here, so sigma 2pz will be 0. So this is the electronic configuration of C2 according to MOT. Now over here, bond order you can find out. So bond order will come out to be 2, that is number of electrons in bonding minus anti-bonding. So over here you can see bond order is 2, but what type of bond is present in C2 molecule? So both the bonds are basically pi bonds. So both are pi bonds. There are 2 pi bonds that are present in C2 molecule. There is no sigma bond. Sigma 2pz is 0. There is no sigma bond present in C2 molecule. So in C2 molecule, you will say there are 2 pi bonds. So 2 pi bonds in C2 molecule. So C is corresponding to 2. And the last one, ethyne. So ethyne, there is carbon, carbon, triple bond. First bond is sigma bond, remaining 2 are pi bonds. So 1 sigma bond and 2 pi bonds. So D is corresponding to 1. So A is corresponding to 3, B is corresponding to 4, C is corresponding to 2, and D is corresponding to 1. So answer will be third option. Come to the next question. So match the following type: ammonia, shape or geometry. So ammonia, there is 1 lone pair and 3 bond pair. Hybridization will be sp3. sp3 hybridization with 1 lone pair and 3 bond pair. The shape is trigonal pyramidal. So A is corresponding to 1. Then BrF5, there are 5 bonds. Bromine is having 7 electrons, so 1 lone pair will be there. 1 lone pair and 5 bond pair. So sp3 D2 hybridization will be there. Total 6 orbitals in bonding or hybridization. So sp3 D2 hybridization with 1 lone pair. The shape is square pyramidal. So B is corresponding to 4. Then XeF4, xenon is having 8 electrons, 4 in bonding and 4 in the form of lone pair. So 2 lone pair and 4 bond pair. So sp3 D2 hybridization only. And with 2 lone pair, it is square planar shape. So C is corresponding to 2. And SF6, all the 6 electrons in bonding. So it will be sp3 D2 hybridization, all the 6 electrons in bonding, that is octahedral. So D is corresponding to 3. So A corresponding to 1, B corresponding to 4, C corresponding to 2, and D corresponding to 3. So answer will be first option. Next question. The E0 value of Mn plus 3 to Mn plus 2 couple is more positive than that for chromium plus 3 to chromium plus 2 or Fe plus 3 to Fe plus 2 due to change of. So what is this? These are basically, it is saying that the reduction potential of manganese plus 3 to plus 2 is more than chromium plus 3 to plus 2 or Fe plus 3 to plus 2. This is because of electronic configuration of manganese. So manganese plus 2. So manganese atomic number 25, manganese plus 2 is 3d5 and Mn plus 3 is 3d4. So because 3d5 is half filled, so manganese plus 3 has more tendency to gain electron and get stable, that is half filled configuration of 3d5. So manganese plus 3 will have tendency to gain electron easily and it will have high value of reduction potential. So it will undergo reduction easily, it will gain electron easily. So that is the reason why the E0 value is more. Due to change of, so manganese plus 3 is D4 configuration and plus 2 is D5 configuration. So due to change of D4 to D5 configuration, that is third option. Don't mark this option, it is saying D5 to D4. It is opposite D4 to D5 configuration. So manganese plus 3 is D4, it will go from D4 to D5 and get stable easily. That is why it will undergo reduction easily and high value of reduction potential is there as compared to chromium and iron. Next question. Which of the following equilibrium constant Kp is not equal to Kc? So Kp is equal to Kc into RT power delta Ng. Now if delta Ng is 0, then Kp is equal to Kc. Now question is asking in which of the following Kp and Kc are not equal. That means delta Ng is not equal to 0. So first one, delta Ng will be 2 minus 1, that is 1. Second one, delta Ng will be 2 minus 1 plus 1, that is 0. Third one, delta Ng will be 1 plus 1, products minus reactant 1 plus 1, 0. All are gases. And in the fourth one also, delta Ng will be 1 plus 1, that is for product, minus gases 0. So delta Ng is not 0 in this one. So in this Kp and Kc will not be equal, others Kp and Kc will be equal. Next question, among the group 16 elements, which one does not show +2 oxidation state? So all the group 16 elements have tendency to show -2 oxidation state. Oxygen, then sulfur, then selenium, then tellurium, then polonium. So these are elements of group 16 which have tendency to show -2 oxidation state. But down the group, the electronegativity decreases. Since the electronegativity decreases, the tendency to show -2 oxidation state also decreases. So down the group, as the electronegativity is decreasing, the tendency to show -2 oxidation state decreases. Now the question is asking, among group 16 elements, which one does not show -2 oxidation state? So answer is polonium. Polonium, down the group, metallic character also increases, so and tendency to show negative oxidation state decreases. So polonium generally in fact shows +2 and +4 oxidation state and shows the metallic nature. So it has the metallic nature and it does not show -2 oxidation state. So answer is fourth option, polonium. Next question, the spin only magnetic moment for which of the following ions is same? So you have to tell magnetic moment spin only, that is given by √n into n+2 Bohr magneton. That will depend upon the number of unpaired electrons. So spin only magnetic moment is same for which of the following. So let us calculate the number of unpaired electrons. If the number of unpaired electrons is same, spin only magnetic moment will be same. So titanium. So titanium +3. So titanium is 4s2 3d2. Now titanium +3 will be 4s0 3d1. So it has one unpaired electron. So over here it will have one unpaired electron. I'm writing over here. Now chromium. Chromium is 4s1 3d5. Now chromium +2 will be 3d4. So chromium +2 is 3d4. It will have 4 unpaired electron. Manganese is 4s2 3d7. Sorry, 4s2 3d5. So manganese is atomic number 25, 4s2 3d5. Now manganese +2 will be 3d5. 2 electrons from 4s will be removed. So manganese +2 has 5 unpaired electron. Then iron atomic number 26, 4s2 3d6. So Fe +2 will be 3d6. So 3d6, there will be 4 unpaired electron. So 2 electrons will be paired. So 4 unpaired. So if the number of unpaired electrons is same, they will have the same magnetic moment. Scandium also you can check. So scandium atomic number 21, 4s2 3d1. So scandium +3 will be, all the 3 electrons will be removed. So 4s0 and 3d0. So there is no unpaired electrons. So 0 unpaired electrons. So it will have magnetic moment 0. So question is asking same magnetic moment, that will be for B and D. So answer will be first option, B and D only. Next, a compound with molecular formula C6H14 has 2 tertiary carbons. So it has 2 tertiary carbons. What do you understand by tertiary carbon? That is attached to 3 carbons and 1 hydrogen. And it has 2 tertiary carbons. And total number of carbon atoms is 6. So the only one structure that is possible with sharing of 1 carbon atom over here. So you can make 2 tertiary carbon like this. So basically these are the 2 tertiary carbon and the structure will be, so what is the IUPAC name of this compound? So IUPAC name will be, if I start the numbering 1, 2, 3, 4 and 5. So over here 1, 2, 3, 4, 5, so 6 and 7. So sorry, this is the structure with 7 carbon atoms. So this is not the structure possible. So let us make 2 tertiary carbon like this. So this is first tertiary carbon. And this is the second tertiary carbon. So 1, 2, 3, 4, 5, 6, 7. Not possible. So with 2 tertiary carbon, this is the only structure possible. 1, 2, 3, 4, 5, 6 with 6 carbon atoms. So this is first tertiary carbon and this is the second tertiary carbon. So the IUPAC name of this will be, if I start the numbering 1, 2, 3, 4. So this will be 2,3-dimethyl butane. So this is the only structure possible with 2 tertiary carbon. Next, given below are 2 statements. The boiling point of 3 isomeric pentanes are given below: N-pentane, isopentane, neopentane. So N-pentane 1, 2, 3, 4, 5, isopentane and neopentane. This is statement 1. So boiling point we know of isopentane is less than that of N-pentane because the surface area decreases, and neopentane is less than this. So this statement is correct. Now statement 2 is saying when the branching increases, the molecule attains the shape of sphere. So with this shape, this straight chain, the molecule is, you can say, cylindrical. With branching, this is attaining the shape of a sphere. This results in smaller surface area. With same volume, the surface area of sphere will be smaller. So with this results in smaller surface area for contact, due to which the intermolecular forces between the spherical molecules weak and thereby lowering the boiling point. So surface area is decreasing with branching, and that will decrease the weak van der Waals forces between the molecule, and the boiling point decreases. So statement 2 is also correct. So both statement 1 and 2 are correct. So answer will be first option. Next question, which plot of ln k versus 1 by t is consistent with Arrhenius equation? So Arrhenius equation is k is equal to a e to the power minus ea by rt, where a is the Arrhenius constant. Now I am taking log to the base e. So ln k will be ln a minus ea by rt. So now we are plotting plot of ln k versus 1 by t. So there will be this y-intercept. So ln a will be the y-intercept, and the slope will be negative minus ea by r. So the y-intercept will be ln a, and this will be slope of this line. This is the equation of straight line with negative slope. So slope of the line will be minus ea by r. So which of the following graph is consistent? Answer will be fourth option. Next question, Henry's law constant values of 3 gases ABC in water are this. The solubility of these gases in water follows. So according to Henry's law, pressure of the gas above the solution is equal to Henry's constant into mole fraction of the gas in the solution. So basically you can say mole fraction, that is solubility of the gas, is inversely proportional to Henry's constant. For the same pressure, the gas that is having lesser value of Henry's constant will have more solubility. So solubility, you can say, is inversely proportional to value of Henry's constant. So the one that is having least value of Henry's constant will be the most soluble gas. Then second number is C option, and then A option. So this will be the order of solubility of gas, that is second option. Next question, Fehling solution A is. So basically there are 2 Fehling solutions. So Fehling solution A and Fehling solution B. So basically these are used to test aldehyde. Basically over here there is aqueous. So basically Fehling solution is aqueous copper sulfate, and Fehling solution B is alkaline solution of sodium potassium tartrate, that is known as ratio salt. And these are used to detect aldehydes and ketones. So over here copper is in +2, that will be reduced to +1. So that will be reduced to +1, and the aldehyde will be oxidized. So this is the test to distinguish aldehyde from ketone. Fehling solution A and B mixture is added. So basically Fehling solution A is only aqueous copper sulfate, and Fehling solution B is this Rochelle salt, that is alkaline solution of potassium and sodium tartrate. So basically question is asking Fehling solution A, that is aqueous copper sulfate. Next, the boiling point of hydrides of group 16 elements are follows. So down the group, if we are moving down the group, the molecular weight will increase. So if the molecular weight increases, van der Waals force of attraction increases, boiling point increases. But there is an exception. H2O will have maximum boiling point. Down the group, the boiling point should increase. So H2TE will have more boiling point than H2SC, than H2S. But H2O has maximum boiling point because of hydrogen bonding. So because of hydrogen bonding present in H2O, because of small size and high electronegativity of oxygen, H2O molecule hydrogen bonding is there, it will have highest boiling point. So this is the order of boiling point of group 16, that is correct. Now on the basis of molecular mass, H2O is expected to have lower boiling point. So on the basis of molecular mass, H2O is expected to have lower boiling point than the other members of the group 16. But due to presence of extensive hydrogen bonding in H2O, it has the higher boiling point. So statement 2 is also correct. So both statement 1 and 2 are correct. Next question. Given below are two statements. So cobalt, hexamine +3, then cobalt, hexafluoride, hexafluoro -3. Complexes are octahedral, but they differ in the magnetic behavior. So cobalt. So in over here, cobalt is in +3 oxidation state. You can check in both. Cobalt is in +3 oxidation state. So cobalt, atomic number 27, electronic configuration 4s2 3d7. Now cobalt +3, electronic configuration 3d6. So this is the electronic configuration of cobalt +3, 1, 2, 3, 4, 5 and 6. Now ammonia being a strong field ligand, that will cause pairing of electrons. So after pairing, these two d orbitals will be empty. So these two will undergo pairing. So this will cause pairing of electrons. So electrons will be paired. And the hybridization of cobalt in this will be D2sp, 3 hybridization, no unpaired electron, it is diamagnetic. So this is diamagnetic, fine. Now in COF6, it is a weak field ligand. Fluoride is a weak field ligand. This is a strong field ligand that will cause pairing. So weak field ligand will not cause pairing. So what will happen? There will be no pairing of electrons. So this is 3d6 for cobalt +3. So the outer S4s, then 4p and 4d will be involved in hybridization. So hybridization over here will be sp3d2, and because of 4 unpaired electron, it will be paramagnetic. So statement 2 is also correct. So both statement 1 is saying both are octahedral but differ in their magnetic behavior. One is diamagnetic, one is paramagnetic. So statement 1 is also correct and statement 2 is also correct. So statement 1 and 2 both are true. Next question. The most stable carbocation among the following. For stability of carbocation, we have to look for the different factors like resonance, then hyperconjugation, then inductive effect. So if you see by inductive effect, this is secondary carbocation, this is also secondary carbocation, this is primary carbocation, this is tertiary carbocation. Now hyperconjugation is a stronger effect. Now if you count the number of alpha hydrogen, 1 over here and 2 over here, total 3 alpha hydrogen over here. Over here 3 + 2, 5 alpha hydrogen will be there, and over here 1 alpha hydrogen only, and over here 2, 4 and 7 alpha hydrogen. So according to inductive effect also this will be the most stable, and according to hyperconjugation also this will be the most stable. But hyperconjugation is a stronger effect, so you have to look according to the hyperconjugation. So this will be the most stable carbocation. Next question. On heating, some solid substances change from solid to vapor state without passing through liquid state. This technique is used for purification of such solid substances based on the above principle. It is known as sublimation. So sublimation is directly converting from solid into gaseous state without vapor. So sublimation is the method used for purification of some of the solids which are easily sublime or which easily get converted into vapors. So the answer will be second option, sublimation. Next question. Match the following type. So this is the complex given. So it can show linkage isomerism. NO2 is an ambidentate ligand. It can show linkage isomerism. So A is corresponding to 2. Then over here, it can show ionization isomerism. The ions can be exchanged and different ions will be formed. So B is corresponding to 3. It is showing ionization isomerism. This one can show the complexes can be changed. So this one can show coordination isomerism. So C is corresponding to 4. This is the example given in NCERT also for coordination isomerism. And this one will show hydrate isomerism. that is solvate isomerism. So solvate or hydrate isomerism. So D is corresponding to 1. So this is also example given in NCERT for solvate isomerism, in which its different isomers are different in colors. So A is corresponding to 2, B 3, C 4 and D 1. So answer will be first option. Next question. The reagent with which glucose does not react to the corresponding test products are. So glucose is having aldehyde group. So glucose will react with Tollens reagent, but due to its hemiacetyl circular formation, it does not react to Skiff's reagent because its aldehyde group is not easily available in its cyclic hemiacetyl formation. And sodium bisulfite is also not easily added because the aldehyde group is not available because of cyclic formation of the hemiacetyl group, and it does not react to 2,4-DNP also glucose because of this aldehyde group is involved in the cyclic hemiacetyl formation. So which of the following reagents does not react to glucose? So Skiff's reagent does not react and sodium bisulfite is not added easily. So hydroxylamine will be added to aldehyde, and hydroxide and hydroxygens are formed easily in this case. So the reagents which does not react will be B and E, that is third option. Next question. Match the list with the reagent. So this is the alkene and we are breaking this double bond, and double bond O is coming. So that is the product of ozonolysis, reductive ozonolysis. So A is corresponding to 4. So in the second case, if I have to make this, I'll be reacting this with acid chloride in presence of anhydrous AlCl3. This acyl carbocation will be formed that will be attacking the benzene ring, and I'll be getting this product. So B is corresponding to 1. So alcohol is oxidized to ketone, so chromium oxide can be used to oxidize this. So C is corresponding to 2, and this basically the alkyl benzenes are oxidized by KMnO4 to the carboxylic acid, or whether irrespective of length of the alkyl chain, it will be always oxidized to carboxylic acid. So we are using KMnO4 in basic medium, so salt of carboxylic acid will be formed. So D is corresponding to 3. So A is corresponding to 4, B is corresponding to 1, C is corresponding to 2, and D is corresponding to 3. So that will be third option is the answer. Next question. The activation energy of any chemical reaction can be calculated if one knows the value of. So this formula you must have studied. Ln K2 by K1 is equal to EA by R 1 upon T1 minus 1 upon T2. So if you know the rate constant at a standard temperature, you cannot find out activation energy. Even if you know the value of rate constant at a fixed temperature, you cannot find out activation energy unless you know the value of Arrhenius constant. Then probability of collision will not give me the activation energy if you don't know that temperature. Orientation of the molecule has nothing to do with the activation energy. Now the rate constant at 2 different temperatures. Now if you know the rate constant values at 2 different temperatures, then you can easily find out activation energy by this formula. So answer will be fourth option. The activation energy of any chemical reaction can be calculated if one knows the value of rate constant at 2 different temperatures. Then come to the next 77, 1 mole of H2O to O2. So if you are converting 1 mole of H2O to O2, oxygen is -2, it is going to 0. So for 1 mole of H2O, there will be 2 moles of electron required. That means 2 Faraday of charge will be required. So 2 Faraday of charge, so A is corresponding to 2. 1 mole of MnO4 minus to Mn plus 2. So MnO4 minus, manganese is in +7 oxidation state to +2. There will be change of 5 electrons. So 1 mole of this, 5 mole of electron, that is 5 Faraday will be required. So B is corresponding to 4. Then 1.5 moles of calcium from calcium chloride. So we are having molten calcium chloride from where we are getting calcium. So calcium chloride, so there will be 2 moles of electron required for 1 mole of this. Now we are having 1.5 mole of this. So 1.5 means 3 by 2. For 3 by 2 moles of this, number of moles of electron required will be 3 electrons. So 3 moles of electrons, that is 3 Faraday will be required. So C is corresponding to 1. So 1 mole of FeO to Fe2O3. So FeO, oxidation state of iron is +2. Fe2O3, oxidation state of iron is +3. Iron is going from +2 to +3. There will be change of 1 mole of for 1 mole of FeO, 1 mole of electron will be required. So 1 Faraday will be required. So D is corresponding to 3. So A is corresponding to 2, B is corresponding to 4, C is corresponding to 1, D is corresponding to 3. Answer will be first option. Next question, the intramolecular hydrogen. So intramolecular is hydrogen bonding is present in, that you must have studied, in the ortho isomer. So meta and para will not show intramolecular, they will show intermolecular. HF will also show intermolecular hydrogen bonding. So intramolecular is present in ortho isomer. Next, aniline does not undergo Friedel-Crafts alkylation reaction. So aniline does not undergo Friedel-Crafts alkylation reaction. So what is the reason? This statement is correct only. So in Friedel-Crafts alkylation, we are using alkyl chloride in presence of AlCl3. So what will happen? So instead of alkyl chloride reacting at this RCl to form the electrophile, that is the carbocation plus AlCl4 minus, this AlCl3 will attack the lone pair of aniline and the electrophile will not be generated. So aniline cannot be prepared through Gabriel synthesis. So this statement is also correct. So both statement 1 and 2 are correct. Next question. Which of the following alcohols reacts instantaneously with Lucas reagent? So Lucas reagent is the test to distinguish between primary, secondary and tertiary alcohol. Primary alcohol does not react with Lucas reagent. Secondary alcohol gives turbidity within 5 to 10 minutes and tertiary alcohol react immediately and give turbidity. So immediately react and give turbidity. So which of the following will instantaneously react with Lucas reagent? That is tertiary alcohol. So this is primary alcohol, this is secondary alcohol, this is primary alcohol, this is tertiary. So tertiary alcohol react immediately with Lucas reagent. Next, arrange the following elements in increasing order of the fast ionization energy. So lithium, beryllium, boron, carbon, nitrogen. So lithium is 2s1, beryllium is 2s2, then 2p1, 2p2 and 2p3. So these are the elements of the same period. So as we are moving along the period, the effective nuclear charge will increase and the ionization energy will increase. So as the effective nuclear charge is increasing, the radius is also decreasing and the ionization energy is increasing along the period. But over here, you have to look for the exception of half filled and fully filled. So this is 2p3 half filled and this is fully filled. So beryllium will be greater than boron. So the correct order will be lithium, then boron, then beryllium, and carbon and nitrogen. So nitrogen will be greater than carbon only. So lithium, beryllium, boron, carbon, nitrogen, that is second option will be the answer. Next question. Which reaction is not a redox reaction? So if you see the first reaction, zinc is going from 0 to +2, copper is going from +2 to 0, both reduction and oxidation. This is redox reaction. KClO3 plus iodine. Iodine is going from 0 to +5. Chlorine is going from +5 to 0. So both reduction and oxidation, redox reaction. Over here, hydrogen is going from 0 to +1, that is oxidation. Chlorine from 0 to -1, that is reduction. So this is also redox reaction. In the last reaction, if you see, the oxidation state is not changing for any of the atom. So this is not a redox reaction. This is just a displacement reaction. So which is not a redox reaction? Answer will be fourth option. Next question. So quantum numbers is given and information provided like ml. M, that is magnetic quantum number. L stands for angular or azimuthal quantum number. N for the principal quantum number. And ms stands for spin quantum number. So spin quantum number will tell me the orientation of the spin of the electron. So B will correspond to 4. A is magnetic quantum number. That will give me the shape of the orientation of the orbital. So basically N, that is the principal quantum number, will give me the size of the orbital. Then the angular quantum number, that is C, will give me the shape of the orbital. And the magnetic quantum number, that is ML, that is A, will give me the orientation of the orbital. So A is corresponding to 3. So angular quantum number will give me the shape like L is equal to 1, that is p orbital. Now there are 3 p orbitals, px, py, pz. So magnetic quantum number will give me the orientation, whether it's p oriented along the x-axis or y-axis or z-axis. So magnetic quantum number is giving me the orientation of the orbital. So A is corresponding to 3, B is corresponding to 4, then C is corresponding to 1, and D is corresponding to 2. So answer will be second option. In which of the following process entropy is increasing? So there is increase in entropy. Liquid evaporates to vapor. So when liquid will evaporate to vapors, so in gaseous state the randomness will be more. So vapors are basically gases. So in gaseous state the randomness of the molecules will be more. So entropy will increase. So entropy increases in this. Now temperature of the crystalline solid is lowered from 130 to 0. So as the temperature is decreased, entropy will be decreasing. So in this, entropy will be decreased, not increased. Then sodium bicarbonate is decomposed to give sodium carbonate CO2. As the gaseous molecules are getting formed from the solid, the entropy will increase. Gases have more entropy, so in this case the entropy will be increased. Now Cl2 gas is giving me 2Cl gas, so delta Ng is positive. From 1 mole of the gas, 2 moles of the gas molecules are formed, so delta Ng is positive, that is 1, delta Ng 1 over here. So in this case also entropy will increase. So A, C and D. So A, C and D, that is third option will be the answer. Next question. A gram of sodium hydroxide was treated with 25 ml of 0.75 ml HCl. So sodium hydroxide is treated with HCl. The mass of the solution of sodium hydroxide reacted is, let us first find out number of moles of HCl, that is molarity. So molarity is 3/4 molar, and volume should be in liters. So these are number of moles of HCl. So number of moles of HCl will be equal to number of moles of NaOH. So these are number of moles of NaOH that is reacting. So mass of NaOH, so from over here we can find out the mass of NaOH that is reacting. So number of moles into molecular weight of NaOH, that will give me the mass of NaOH that is reacting over here. So 75 into 10 to the power minus 2, that is 0.75 grams. So 0.75 grams of NaOH is reacting. So we were having 1 gram, out of 1 gram 0.75 is reacting. So remaining will be 0.25 grams. So the mass of sodium hydroxide unreacted is 0.25 grams. That is nothing but 250 milligrams. So answer will be second option. Next question. The products A and B obtained in the following reaction respectively are, so alcohol when reacted with PCl3, so PCl3 and PCl5 both are chlorinating agent, alkyl chloride will be formed, and in this case H3PO3 will be formed. So A is nothing but H3PO3, and in the second case when you are using PCl5, then POCl3 will be formed. So alkyl chloride plus HCl plus POCl3 will be formed. So B is nothing but POCl3. So H3PO3 and POCl3. Answer will be fourth option. Next question. The major product A and B formed in the following reaction sequence. So PbR3 is a brominating agent. So what will be A over here? So A will be the alcohol, will give me the alkyl bromide over here, and CH3 will be over here. So this is A. Now alcoholic KOH. So alcoholic KOH will do dehydrohalogenation and alkene will be formed. More substituted alkene with more number of alpha hydrogen will be formed. So this alkene will be formed, that is more substituted alkene. So this is B. So more substituted alkene will be formed. So answer will be first option. Next question. Identify the major products. So alkyl iodide with NaCN. So what will be A? So this will be A. Now A partial hydrolysis is taking place. So what will be B? Cyanide on partial hydrolysis will give me amides. So amide will be formed. So this is B, amide. Now NaOH, so Hoffman bromomide degradation, NaOH and Br2. So from amides, amines will be formed with 1 carbon atom less. So this will be the amine form with 3 carbon atoms. So this is C, the amine that is getting formed. So product C formed in the following is propylamine with 3 carbon atoms. So answer will be first option. Next question. During the preparation of Mohr salt. So what is Mohr salt? Ferrous sulfate dot ammonium sulfate. Now in this ferrous ammonium sulfate, so that is Mohr salt, preparation of Mohr salt, which of the following acid is added to prevent hydrolysis of ferrous ion? So ferrous ion is easily oxidized to ferric ion in presence of oxygen that is present in the air, and in aqueous solution water will be there. These ions are in aqueous solution. So ferrous ions are easily oxidized to ferric ions. To prevent the hydrolysis and oxidation of these ferrous ions, dilute sulfuric acid is added. So that will decrease the pH of the solution. So dilute H2SO4 will decrease the pH and prevent the oxidation and hydrolysis of these ferrous ions. So answer will be fourth option. Next question. Consider the following reaction in a sealed vessel at equilibrium with concentration. So concentration is given at equilibrium. So equilibrium constant Kc for this reaction will be concentration of N2 at equilibrium, concentration of O2 at equilibrium divided by concentration of NO at equilibrium whole square. So these are the concentrations given at equilibrium. So at equilibrium, these are the concentrations given. So from here we can first find out the Kc of this reaction. So N2, it is 3 into 10 to the power minus 3. O2 is 4.2 into 10 to the power minus 3 upon 2.8 into 10 to the power minus 3 whole square. So this is the value of Kc. Now 0.1 mole per liter of NO gas is taken in a closed vessel. What will be the degree of dissociation of alpha for NO at equilibrium? So let the degree of dissociation is alpha that we have to find out. So out of 1 mole, alpha mole will be dissociated, alpha by 2 of this and alpha by 2 of this will be formed. The initial concentration is 0.1, so 0.1 will be multiplied over here. So at equilibrium, we have to find out the degree of dissociation, that is alpha. So at equilibrium, the concentration of NO will be 0.1 alpha by 2, O2 will be also 0.1 alpha by 2, and that will be 0.1, 1 minus alpha whole square. So 0.1 square will be cancelled out. So that should be equal to this value. So if we solve this, 7 4s 5 6 then 2 and this is 3. Okay. So this will be 3 square into 3 into 10 to the power minus 3. So I am writing 3 into 10 to the power minus 3 whole square upon this will be 2 into 10 to the power minus 3 whole square. Like this we can write down. Now if I am taking under root, so alpha by 2 and 1 minus alpha will be equal to 3 into 10 to the power minus 3 upon root 2 into 10 to the power minus 3. This is getting cancelled out. So we have to find out the value of alpha. If I take alpha over here, so 1 of this will be, so root 2 will be remaining. So alpha is equal to 3 root 2 minus 3 root 2 alpha. So from here we can find out alpha. So alpha will be equal to 3 root 2 minus 3 root 2 alpha. So if we have to solve 1 plus 3 root 2 alpha is equal to 3 root 2. So alpha will come out to be 3 root 2 upon 1 plus 3 root 2. So putting the value of root 2, we have to find out the value of alpha over here. So the value of alpha will come out to be 0.0889. So answer will be second option, 0.0889. Next question, the work done during reversible isothermal expansion. So what is the work done in isothermal expansion? Minus nRT ln V2 by V1, and in terms of pressure minus nRT ln P1 by P2. So this is the work done in isothermal process. Isothermal expansion of 1 mole of the hydrogen gas. So N is 1 mole of the hydrogen gas. Temperature is 298 Kelvin, 25 degrees Celsius. P1 is 20 atmosphere. P2 is 10 atmosphere. So work done we can calculate minus N, and work done in calories if we are calculating R will be 2. Temperature is 298 ln P1 by P2. 20 by 10 ln 2. So 2 minus 2 into 298 into ln 2 is 0.693 you can take. So 298 into 0.693, so this will come out to be minus 413.4 calories will be the answer. That is second option. Next question, mass in grams of copper deposited by passing current. So current is how much? 9.6487 ampere through a voltmeter containing copper sulfate solution for time 100 seconds. So charge will be current into time. 964.8 coulomb will be the charge. Now 1 Faraday is given 96487 that we have to take. So number of moles of electron that is passed is total charge 964.887 divided by 96487 that you have to take. So that is 1 by 100. So 10 to the power minus 2 moles of electrons are passed. So copper plus 2 ion will take 2 moles of electron and copper solid will be deposited. So number of moles of electron we know that are passed. So number of moles of copper will be half the number of moles of electron. So number of moles of copper will be how much? That is half the number of moles of electron. And we have to find out the mass of copper. So mass of copper will be number of moles of copper into molecular weight of copper. So this will come out to be 331.5. So 0.315 grams will be the answer. So second option is the answer. Rate of a reaction quadruples when the temperature changes from 27 degrees Celsius, that is 300 Kelvin, to 57 degrees Celsius, that is 330 Kelvin. So rate of the reaction quadruples. So K2 will be 4 times that of K1. Activation energy we have to find out. So ln K2 by K1 will be EA by R 1 upon T1 minus 1 upon T2. So this will be ln 4. Log 4 value is given. So ln 4 we can convert into log. So 2.303 and this will become log 4. Log 4 value is 0.6021. Activation energy we have to find out. ER value is 8.314. So 330 minus 300, that is 30 by 300 into 330. So from here we'll get the activation energy in joules per mole. If we want in kilojoules per mole, we have to divide this value by 1000. So activation energy will come out to be 2.303 into 0.6021 into 8.314 into 300 into 330 by 30. And if you want in kilojoules, divide by 1000. So this will be kilojoules per mole. So 2 and 1, 3 zeros gone. And 3 tens are. Now you have to find out this value. 33 into 8.314. So this will come out to be 33 into 8.314 around. Then this will be approximately 380, 33, no less than 330. Then 0.602 and 2.303. So around 380, then divided by 10. So if you take around 380, then divide 38. So 38.04 in kilojoules, it will come out to be 38.04. So this will be the answer. The plot of osmotic pressure versus concentration for a solution is given as a straight line with slope. So pi is equal to CRT. So pi versus concentration plot is given, slope will be RT, that is 25.73 liter bar per mole. The value of R is also given in liter bar. Temperature at which this osmotic pressure is done will be 25.73 by 0.083. This will be the temperature in Kelvin. So this will come out to be 3110 Kelvin, and if you want in degrees Celsius, so this will be 37 degrees Celsius. So answer will be first option, 37 degrees Celsius. Next question. Given below are certain cations using inorganic quantitative analysis. Arrange them in increasing order of group number from 0 to 6. So aluminium is in group 3, copper is in group 2, barium is in group 5, cobalt group 4, and magnesium is in group 6. So increasing order, B, then A, then D, then C, then E. So this will be the order B, A, D, C, E. So first option is the answer. Given below are two statements. This is an homoleptic complex. So there are two kinds of complex, homoleptic and heteroleptic. So what are homoleptic? Which are having same type of ligands. What are having that have more than one type of ligand. So this is an heteroleptic, this is homoleptic. So this statement is correct. Now complex has only one kind of ligand. So this complex has only one kind of ligand, but this complex has more than one kind of ligand. This statement is also correct. So both statement 1 and 2 are correct. The pair of lanthanides which are diamagnetic. So cerium plus 4. So this will be 5s2, then 5d1, then 4f1. So cerium plus 4 will be, all the 4 electrons will be removed. So 0 electrons, that is no unpaired electron. And ytterbium plus 2. So this will be 4f14 and 5s2. So plus 2, this will be removed. This is also no unpaired electron. So this will be also diamagnetic. So these both are diamagnetic. They will not have any unpaired electron. So answer will be first option. So oxidation of alkenes with KMnO4 in acidic medium. The alkenes will be oxidized to aldehydes, ketones or carboxylic acid. So generally the aldehydes will be oxidized further to carboxylic acid. So if the aldehyde that is formed, that will be further oxidized to carboxylic acid over here. So the final product will be carboxylic acid. So 2 moles of this will be formed. So this will be the product. Identify the correct answer. 3 resonating structures are possible for ozone. For ozone, 2 resonating structures are possible. So these are the 2 resonating structures possible for ozone. So this is not correct. BF3 has non-zero. So BF3 has zero dipole moment. This is saying non-zero dipole moment. So this is also not correct. So BF3 being symmetrical molecule, triagonal planar in shape, this is dipole moment is 0. Next, dipole moment of NF3 is greater than that of NH3. So dipole moment of NF3 is less than that of NH3. This is the question of NCERT. So because of direction delta negative, delta positive, these will be cancelling out. So dipole moment of NF3 is less than that of NH3 based on NCERT. So this is all greater than that of NCERT. That is also not correct. You have to tell the correct answer. So 3 canonical forms can be drawn for carbonate ion. So for carbonate ion, you can draw 3 structures. So this is one. Then you can draw the second one. And the third one will be So these are the 3 canonical forms of carbonate ion. So for carbonate ion, 3 canonical forms are possible. So this is the correct statement. You have to tell the correct statement. Answer is 4th option. Next question. A compound X contains 32% of A. So compound X contains 32% of A and 20% of B and the remaining percentage of C. So 30 plus 20, 52. So remaining will be 48. 48% of C. The empirical formula, molecular weight of A is given. So A is 64, B is 40 and C is 32. So this will be 1 by 2. This is also 1 by 2. This is 16 3s are 16 2s are. Now multiplying by 2, 1 1 3. So the empirical formula will be A1 B1 C3. ABC3 will be the empirical formula. So with this we finish with the paper. So thank you.